Have you ever actually stopped and just looked down? I mean, really looked at the dirt, the grass, or the pavement beneath your feet and wondered about its lifespan? We walk on it, we build massive cities on it, and we constantly extract from it every single day, just completely assuming it's always going to be there. But what if I told you that the ground you're standing on right now isn't some limitless magical resource? What if, actually, it's an incredibly fragile, vanishing asset that we are burning through at a really alarming rate?
Welcome to this explainer. I am super excited to have you here with us today. Because in this explainer, we are going to completely flip the way you look at the physical world around you. We're diving deep into the core themes of geographic and environmental sustainability. Specifically, we're talking about resources and development. We're going to look at the hard data, peel back the actual physical layers of our Earth, and figure out exactly what we have, how we're using it, and maybe most importantly, how we might just be able to save it.
So here's our game plan for today. First, what are resources? Second, the resource crisis. Third, India's land use pattern. Fourth, classifying our soil. And fifth, soil erosion and conservation. Let's get right into it.
Okay, let's dive into part one. What are resources?
Now, you might think a resource is just, any random object sitting out there in nature, but the actual definition, it is incredibly specific, and it's absolutely crucial we understand it. For something to actually be a resource, it has to be technologically accessible, meaning we literally have the tools to go get it. And just as importantly, it has to be economically exploitable. I mean, if it costs us $10 billion to dig up $1 worth of a mineral, yeah, that's not a functioning resource. It has to satisfy a human need and actually make sense to extract.
When you look at how we classify everything, it's honestly like a giant puzzle. It immediately splits into two main branches: natural and human resources. On the natural side, you've got this massive critical divide. You have your renewable resources, things like wind, water, and forests that can naturally replenish over time. And then you have your non-renewable resources, like metals and fossil fuels, which literally take millions of years to form. Every single thing that powers our modern everyday lives lives somewhere on this chart.
Which brings us to the so what factor, part two, the resource crisis.
For centuries, humanity kind of operated under this dangerous assumption that all these resources were just an endless free buffet, right? Just free gifts of nature. Well, the results of that assumption are the major ecological nightmares we are dealing with right now. This wild, indiscriminate exploitation, driven mostly by individual greed, hasn't just depleted the Earth. It has literally fractured our societies, creating this massive divide between the haves and the have-nots. And, ecologically, it's triggered massive global crises, from the ozone layer depleting to severe, widespread land degradation. Let's move on and see how this builds. Part 3. India's land use pattern. Let's zoom in geographically and talk about the actual ground in India. It is definitely not a one-size-fits-all situation. About 43% of the land is plains, so that's your agricultural engine and where most of the infrastructure is built. Then 30% is mountains, which are absolutely vital for water resources and tourism. And the remaining 27%? Plateaus. Those hold immense critical reserves of minerals, fossil fuels, and forests. These specific percentages literally dictate how humans survive and drive the entire economic activity of the nation. But how are we actually using all that space? If you fast forward from 1960 to 2008, the data tells a pretty wild story. The net sown area eventually hits 46.24%. That means almost half the entire country is actively being farmed. But if you look at the smaller categories, you'll see fascinating shifts over the decades in wasteland and areas used for non-agricultural purposes. That's essentially roads, buildings, and industries slowly eating their way into the natural landscape over time. But out of all the data out there, this is the statistic that really stopped me in my tracks: 23.81%. That is India's actual forest cover. Why is that a big deal? Because to maintain healthy, functioning ecological balance, the prescribed forest cover is supposed to be 33%. We are falling dangerously below the safety net needed to keep our environment stable.
So where is the land actually going? Well, degradation isn't just one big bad guy. It totally changes depending on human behavior in specific regions. For example, in Jharkhand, Chhattisgarh, and Odisha, mining excavations leave these massive, unhealable scars on the earth. Over in Gujarat and Rajasthan, overgrazing strips away the protective grass, letting the wind just blow the topsoil away. Up in Punjab and Haryana, they're actually over-irrigating, which waterlogs the soil, spikes the salinity, and ruins it. And in our major metropolitan cities, industrial effluents are literally poisoning the ground beneath them. let's zoom in even further, right down to the microscopic level. Part 4, classifying our soil. Okay, picture the Earth like a giant layer cake. This is our physical baseline, the soil profile. At the very bottom, you've got solid, unweathered bedrock. Then you move up through the substratum, into the subsoil, but the most critical layer, the layer that literally supports almost all terrestrial life on Earth, is that incredibly thin band right at the topsoil. This is the only layer that contains humus, the organic matter that plants need to grow. It is shockingly thin, and it is incredibly precious. Now, in India, the most widespread soil type is alluvial soil, which is deposited by these massive river systems. But even within alluvial soil, it has kind of a split personality based on its age. You've got the older stuff called Bangar. It's usually found further away from the rivers, it's definitely less fertile, and it's full of these hard calcium carbonate nodules called canker. Contrast that with the younger soil, Kadar. Kadar is right there on the floodplains, it gets frequently renewed by floods, it's super fine, and it is highly, highly fertile. Then there's black soil, also known as Regur. This stuff is a real game changer. Found mostly in plateau regions like Maharashtra, it has this super rich, dark, clumpy texture made of extremely fine clay. And its superpower? It holds moisture like an absolute sponge. Plus, it's rich in calcium carbonate and potash. All of this makes it the absolute undisputed champion environment for growing cotton. Moving along, we hit red and yellow soils. And honestly, some of these landscapes literally look like the surface of Mars. But that striking color isn't a total accident. The soil gets that reddish tint because of the diffusion of iron oxides inside the rocks. And here's a fun fact, it only looks yellow when it's in a hydrated form. It ends up being the perfect terrain for growing things like potatoes, maize, and certain fruits. Finally, we have arid soils, which is what you'd typically find out in Rajasthan. This is a tough, harsh environment. The soil is incredibly sandy and highly saline. Actually, in some spots, the salt content is so high that you can obtain common table salt just by evaporating the water from it. No way, right? Because it's so dry, it basically has zero humus. So, to make this soil agriculturally viable, it requires massive, intentional human intervention through intense irrigation. So, the crucial point we are driving towards is Part 5, Soil Erosion and Conservation. When things go wrong, we're talking about soil erosion. It's a simple concept, but man, it is deadly. It's the wearing away and washing down of the soil cover. Usually, nature balances soil formation and erosion perfectly, but we humans, we shatter that balance. For example, when running water rapidly cuts deep channels through clay-heavy soils, we call that gully erosion. It aggressively tears up the land, leaving behind completely uncultivable terrain that is literally called badlands. The visual reality of this is honestly pretty hard to stomach. When rapid deforestation rips out the tree roots that hold everything together, or when unchecked overgrazing completely strips away the grass, the topsoil is totally exposed. The harsh wind and water take over, and the earth simply fractures, cracks deep down, and blows away. It's a really stark, sobering reality of what happens when ecological systems fail. But hey, it's not all doom and gloom. We are not totally helpless here. There are incredibly smart, actionable agricultural methods we can use to hit the brakes on this degradation. First, there's contour plowing, plowing along natural contour lines to physically slow down the water flow. Second, terrace farming, literally cutting steps into hillsides to stop the soil from sliding down. Third, strip cropping, planting strips of grass between crops to act as natural speed bumps for the wind. And fourth, shelter belts, planting rows of trees that act as windbreakers. They actually use this brilliantly to stabilize the shifting sand dunes in western India. Which kind of leaves us with one massive, lingering question. Nature takes literally millions of years to build the complex, foundational soils that we absolutely rely on. Yet, as a society, we can completely burn through them in just a matter of decades. Think about those conservation methods we just talked about. Are we actually implementing them fast enough and on a grand enough scale to secure our future? It really challenges how sustainable our modern world actually is. Thank you so much for hanging out with me on this explainer. Keep asking those big questions, and I'll see you next time.